word science originates from the Latin verb scientia, meaning to know. The Sanskrit word vignan and the Arabic word ilm convey similar meaning, namely knowledge. Science, in a broad sense, is as old as human species. The early civilization of Egypt, India, China, Greece, Mesopotamia, and many others made vital contributions to its progress. From the 16th century onwards, great strides were made in science in Europe. By the middle of the 20th century, science had become a truly international enterprise, with many cultures and countries contributing to its rapid growth. What is science? And what is the so-called scientific method? Science is a systematic attempt to understand natural phenomena in as much detail and depth as possible, and use the knowledge so gained to predict, modify, and control phenomena. Science is exploring, experimenting, and predicting from what we see around us. The curiosity to learn about the world, unraveling the secrets of nature, is the first step towards the discovery of science. The scientific method involves several interconnected steps: systematic observations, controlled experiments, qualitative and modeling, prediction, and verification or falsification of theories. Speculation and conjecture also have a place in science, but ultimately, a scientific theory to be acceptable must be verified by relevant observations or experiments. There is much philosophical debate about the nature and method of science that we need not discuss here. Physics is a basic discipline in the category of natural science, which also includes other disciplines like chemistry and biology. The word physics comes from the Greek word physis, meaning nature, introduced by the ancient scientist Aristotle. Man has always been fascinated by nature. So, he questioned and sought answers for every phenomena nature could offer. Its Sanskrit equivalent is bhautiki, that is used to refer to the study of the physical world. The branch of science which is devoted to the study of nature and natural phenomena is called physics. It is expected that all the events in nature take place according to some basic laws. Physics reveal these basic laws from day-to-day observations. The knowledge of physics accumulated till 1900 is called classical physics, that deals with macroscopic phenomena. It includes subjects like mechanics, thermodynamics, electromagnetism, and optics. The recent knowledge beyond 1900 is termed modern physics, consisting of two basic theories: relativity quantum mechanics. The scope of physics is described briefly in the next section. In physics, we attempt to explain diverse physical phenomena in terms of a few concepts and laws.
Welcome to the family of Vivek Kumar Srivastav. To get updated with the latest videos and podcasts, please subscribe to us and press the bell icon.
Overview of physics, scope and its applications in society. Science, etymological meaning, comes from the Latin verb scientia, which means to know. Origin, science is as old as the human species. From the 16th century onwards, great strides were made in science in Europe. Definition: science is a systematic way of acquiring knowledge about the surroundings by careful observations and experimentations over a period of time. Steps involved in a standard scientific method. Systematic observation, controlled experiments, qualitative reasoning, quantitative reasoning, mathematical modeling, prediction, verification or falsification of theories. Nature of science. Science is ever dynamic. There is no final theory in science. Modifications can be made in the established scientific laws. Physics. It is a branch of science. Etymological meaning comes from a Greek word meaning nature. Definition: study of nature and natural phenomena, put in an organized way in various subtopics. Scope of physics. The macroscopic domain includes phenomena at the laboratory, terrestrial, and astronomical scales. The microscopic domain includes atomic, molecular, and nuclear phenomena. Branches of physics. Mechanics, concerned with the motion of particles, rigid and deformable bodies, and general systems of particles. Electrodynamics deals with electric and magnetic phenomena associated with charged and magnetic bodies. Optics deals with the phenomena involving light. Thermodynamics deals with systems in macroscopic equilibrium and is concerned with changes in internal energy, temperature, entropy, etc. of the system through external work and transfer of heat. Scope explains every phenomena occurring in nature on the basis of established rules. Involves the study of phenomena at the very small scales of subatomic level as well as the phenomena involving very large measurements. Applications in society. Physics and technology are related to each other. Both have a direct impact on society. Technology is the application of the principles of physics for practical purposes. Physics acts on behalf of and helpfully to the benefit of mankind. The modern developments in physics have catered to fulfill the needs of society and make their lifestyles more comfortable. The developments of radio, television, satellites, and means of transport have helped the society. Fundamental forces in nature. Physics has revealed that all the forces occurring in different contexts arise from a few fundamental forces in nature. These fundamental forces are as follows. Gravitational forces, weak nuclear forces, electromagnetic forces, strong nuclear forces. Gravitational force, proposed by Newton. Force of mutual attraction is directly proportional to the product of the masses and inversely proportional to the square of the separation between them. Weakest forces in nature. Weak nuclear forces. Discovered during the study of the phenomenon of beta decay in radioactivity. These are the forces of interaction between elementary particles of short lifetimes, about 10 to the power of 25 times stronger than gravitational forces. Electromagnetic forces. Forces between charged particles. The moving charges produce magnetic effects. Electric and magnetic effects are inseparable. Hence, the term electromagnetic. These forces may be attractive or repulsive. Electrostatic forces are 10 to the power of 36 times stronger than gravitational forces. Operate over small distances. Strong nuclear forces. These forces bind the neutrons and protons together in different nuclei. Short-range forces operate within the distances of the order of 10 to the power of minus 14 m. Strongest forces in nature, 10 to the power of 38 times stronger than gravitational forces. Attractive in nature. Unification of forces. Serial number, name of physicist, achievement in unification. 1. Isaac Newton. Unified terrestrial and celestial mechanics. 2. Hans Christian Ørsted. Electric and magnetic phenomena. Electromagnetism. 3. James Clerk Maxwell. Unified electricity, magnetism, and optics showed that light is an electromagnetic wave. 4. Sheldon Glashow, Abdus Salam, Steven Weinberg. Weak nuclear force and the electromagnetic force can be viewed as different aspects of electroweak force. 5. Carlo Rubbia, Simon van der Meer. Verified experimentally the predictions of the theory of electroweak force. Nature of physical laws. In addition to finding the facts by observation and experimentation, physicists attempt to discover the laws that summarize, often as mathematical equations. These facts. Conserved quantities. A remarkable fact is that these are some special physical quantities that remain constant with time. Example, energy, linear momentum, angular momentum, charge, gravity, etc. Law of conservation of energy. For motion under an external conservative force, the total mechanical energy, that is, the sum of kinetic and potential energy of a body, remains constant. Example: free fall of an object under gravity. If the object is released from rest, the initial potential energy is completely converted into the kinetic energy of the object just before it hits the ground. The sum of potential energy and kinetic energy of the ball remains the same at every point during its fall. The law of conservation of energy is valid for any kind of transformation between different forms of energy or across all domains of nature, from the microscopic to the macroscopic. Law of conservation of linear momentum. In the absence of an external force, the linear momentum of a system remains unchanged. Law of conservation of angular momentum. If the total external torque acting on a system is zero, then angular momentum of the system remains constant. Law of conservation of charge. Charges are neither created nor destroyed, but are simply transferred from one body to another. In many cases, conservation laws simplify the problems. Using conservation laws of energy and momentum for beta decay, Pauli predicted the existence of a new particle called neutrino emitted along with electron in beta decay. Note: conservation laws have a deep connection with symmetries of nature. For example, laws of nature do not change with time. Laws of nature are the same everywhere in the universe. Conservation of parity. Conservation laws are now widely regarded as some of the most fundamental laws in all of nature. It was a great shock. Therefore, when two American physicists, Val Lodson-Fish in 1923 and James Watson Cronin in 1931, discovered in the mid-1960s that certain subatomic particles known as K-mesons appear to violate a conservation law. That law is known as the conservation of parity, which defines the basic symmetry of nature, that an object and its mirror image will behave the same way. Scientists have not yet fully explained this unexpected experimental result.
इस चैनल को लाइक कीजिए, सब्सक्राइब कीजिए और सबको इसके बारे में बताइए।